All right. So yeah. So like I mentioned earlier, the recreational water illnesses are the first to be considered. Then economic impact, like I said, the revenue will be on the downturn, and then also social impacts for people that prefer to socialize using the beaches. Most of these beaches, once they're closed for a longer time, longer period of time, that can be an effect, and that can take a toll on them. I mean, coming down with various mental issues and all of that when they don't have the opportunity to go out to socialize. And then long-term environmental health risks. So most of these beaches, sometimes they can be contaminated with agents that could impact the aquatic life, right? They could injure the aquatic life. So, and we know the importance of aquatic life in maintaining the balance of the ecosystem, right? So once this aquatic life are affected, that can outturn the balance of the ecosystem. So yeah, so that's also an effect can have. So, as a form of background, in state of Illinois has about 363 licensed public beaches, and for the year swimming season or swimming year 2024, 315 of them sampled or reported samples. Right. So by standard, they should report bi-weekly, twice every month. That's every 2 weeks, and they should report two samples every 2 weeks. Right. So, and then sampling categories, like I mentioned, the deep and the shallow category, shallow part of the beach. So they are supposed to sample by each sample. They're supposed to take a sample from the deep part of the beach and also the shallow part of the beach. And then the exceedance of this, the coliform limits, usually will trigger the advised regulatory actions. It can be advisory or closures. And then the number of sample analysis techniques that are being used by laboratories across the states. But the ones that, for the purpose of this project, the ones that were majorly used or pay attention to was the Collinons and then the qPCR. And then for these analysis techniques, the limit or the threshold is different. So for Collinons, it's 235 coliform units per 100 mils. And then for for qPCR, it's 1,000 per 100 mil. And then so this project also involved data collection. So the procedure of data collection is we relate with the local county or the county health departments or the county authorities, which collect samples from these individual beaches. So they collect the samples, right? They collect the results rather, and then they relate it to us, and then we end up entering it into BeachGuard. And BeachGuard is the application that contains all the information, the activities about every beach, every licensed beach in the state of Illinois. And then also went ahead with data cleaning and verification process. So when entering this data, we basically try to ensure that do some quality assurance by cross-checking with them, and then okay, if there's a missing information, this is missing, how do we get these and all of that, or probably there's a wrong information, or we just want to confirm an information about the result that is being sent. So we do a lot of quality assurance as well with this data before we get them entered into BeachGuard. And then water quality at Illinois beaches can be influenced by heavy rainfall. So as stated on the swimming facility program page, there was a sort of an hypothesis, for lack of better words, that we found there before we even started in the course of the project that stated that water quality at beaches can actually be influenced by heavy rainfall. So, and that's really informed and further solidify what we are doing or what we did in the project. All right, that gave a background to it that there's a possibility which the research later confirmed. So, talking about the objectives, right? Talking about the objectives, first objective was to identify the impact of weather patterns on coliform contamination levels. So that's been very important. So the missing link that we talked about earlier, we found out that okay, what are the factors that can actually influence these contamination levels, and that possibly is the weather pattern. So we looked at the pattern of temperature, and then of temperature level, and also the rainfall pattern as well. And then also based on these, based on the impact of the weather patterns, another objective was to identify the high risk period for contamination. So based on this, maybe where there's a heavy rainfall we want to identify this as an high risk period, or probably the temperature is very hot or is very high. That's also an high risk period. So, and also we want to recommend, based on this high risk period, we want to recommend optimized water sampling strategies to minimize health risk. So we want to optimize the strategy instead of the bi-weekly standard of sampling. There should be some sort of flexibility to this in terms of based off of the fact that there's an influence or there's a correlation between weather pattern and then the contamination level, and also enhance the efficiency of regulatory actions by providing actionable insights from this data analysis. So we want to be sure that, okay, what we are doing, we are not just closing beaches for closing sake, and we're actually closing beaches when the beach is actually contaminated. I mean, for example, you tell, based on the current protocols, you're supposed to sample twice a week, and then a beach samples now, and then the next 1 week. I mean, the normal should be that, okay, the ideal based on the current protocol should be that the person should sample, the beach should sample in the next 2 weeks, and then at the end of that 1 week, there's a heavy rainfall or the temperature goes haywire, and then they're supposed to sample at that particular time, but they didn't sample part the beach by the regulatory actions that say, okay, you have to sample twice. That means they missed out on that exceedance, and then the public will be exposed to that period of time. They'll be exposed to that high amount of the bacteria, and then that's an high risk. So we want to make sure that we are closing the beaches when they are supposed to be closed, and not just by the rules. All right. Yeah. So also to improve. Another objective was to improve the public health outcomes by reducing exposure to contaminated water, and also based off on the results, propose policies or recommendations that could be of importance, or that could be of benefit to the current monitoring practices. And also we want to explore, based off on the research that we did, we found out that, okay, we didn't exhaust all the factors that could influence the contamination level. So, I mean, this is a research that will birth further research in this line. All right. So, for form of methodology, so we collected the coliform count, or the data of the coliform count, from the Illinois Beach Guard. Like I said earlier, the data were collected first from the county health department authorities, and then it's been entered into the Beach Guard application. And then for the purpose of this research, we collated those data, or the data from Beach Guard about all these beaches for the 315 beaches that sampled for the year of 2024. All right, and then our analysis came down on frequency. So because we were really limited based on in terms of human resources, we had to come down on the number of beaches that we would do or would interpret data for, right? And then we did that focusing on the frequency of the non-compliant sample. By non-compliant sample, I mean the samples that are above exceedance or that are above the limit, right? And then based on this, we group them into the beaches that have the highest number of non-compliant sample, beaches that have the median number or median count of non-compliant samples, and also beaches that have the lowest number of non-compliant samples. So in essence, the one with the lowest number of non-compliant samples, they're the good beaches, quote and unquote, right? So we divided into two. So that gives us like 31 beaches to work with, right? So we went ahead to search for the weather data from two major sources, NCEI and Weather on the Ground website, for the period of January to December 2024, and credit to them for providing us with the information. All right. Okay. Yeah. So we focused on, usually the sampling season or the swimming season usually lasts from the Memorial Day to the Labor Day. So we only focused on those periods. So those are the periods that they sample, the beaches open, they operate, and then they sample, and then they send samples. So we had to focus on that, and then giving the active 124 observations majorly, alongside the corresponding weather data for those observations. So our independent variable, we used the regression model, to analyze these, and then our independent variables based on this model were precipitation and temperature, and then the dependent was the coliform count. So result. Okay, so the results. So overall findings, we found that there were 561 advisory days, and then there were 1,468 closure days, and then there were 405 regulatory actions issued, with that is the 105 advisories and then 300 closures, and then there were about 96% of beach days that were contamination free. Like, I mean, there were 90. Well, another way of saying that were 96% of days, total number of days between that span of time that the beaches were open, right? Yeah. So research findings. Basically, we noticed that elevated coliform count were found during warm periods and after heavy rainfall. And that stands to reason because bacteria generally, by their nature, they thrive in warm temperature or in warmer temperature or in warmer climates. And also heavy rainfall as well, by the reason of runoffs. When there's heavy rainfall, there's tendency for us to have runoffs from farms around, agricultural firms around, and then also you're bound to have runoffs from septic tanks, from toilets, name it, any source of contamination around when you have a heavy rainfall. And also when you have a heavy rainfall, usually rainfall are usually acidic. So when you have an heavy rainfall, it usually increases the acidity of the beaches. And coliform bacteria have been found to thrive better when the pH is less than between 6 and 7, and even less than that. They thrive better based on that. So that will increase their survival rate and their the survival period, and then you can have more of them being contaminating the beaches. And also, we noticed that July recorded the highest contamination level, 20.2% exceedance rate, which is very important. So that means when we are trying to generate policies and make up recommendations for these, we should focus on that month when we are trying to educate beach managers as well, which I will still talk about. Sorry. All right, so yeah, so for the regression analysis, so we noticed that there was 42.3% variability in coliform counts explained by the weather, which is very significant by the results. So it shows that weather patterns actually really affect or influences this contamination level. Also, we found out that temperature showed a very strong positive correlation, right? So for every 1 degree rise in temperature, it was found that there was 7.37 units rise in the coliform count. And as well, we found out that for the precipitation, for every 1 inch rise in precipitation, there was 28.53 unit rise in the coliform count. So, and this could be due to the factors I mentioned earlier, pH and agricultural runoffs, right? Okay, so I mean, there's no project or there's no research that wouldn't have its own challenges. And then, so this research is no exception. We were able to come across some challenges, and then we're able to overcome it. But I mean, these are challenges that could be put into notice, and then, of course, worked on for better future research or easier future research. Then, so the first challenge we had was the weather data. So like I said earlier, they did a good job by providing us the data, but there's always a room for improvement. So we noticed that once we put in the location of the beach on this website, and for the present data for that day, for that particular day, we have an accurate weather data for that. So they have the weather data for that exact location for the present day or for the present time. But when you're trying to look for an historical data from that same website, it gives you maybe 30 miles away or 40 miles away from that particular facility, which further reduces the accuracy or the precision or how precise that information is. And probably, maybe really, if we had the opportunity to have the exact location, the data, historical weather data on the exact location, probably would have improved the correlation that we noticed or the results in general that we noticed. So that's something that can be worked on. Then missing our outdated weather data as well. So there were even some regions that we couldn't even get the weather data at all from. I mean, we couldn't even get the data from. And then also, so this also shows the the discrepancy or let me say the deficit in terms of beaches reporting. So, I mean, we noticed that out of 363, only 315 sampled for the year. And even out of that 315 that sampled, most of them didn't sample up to the standard that was required of them. So most of them had to sample twice a week. Some of them are sampling once a week, once every 2 months. And if we had, if all of them had sampled, we would have had a bigger or a larger data set to work with. And that would have improved the correlation that we later got, right? So yeah, so sample result availability is something to work on. And then, like I said, wider range of analysis, then also that would increase correlation. And then incomplete coordinates of some beaches. So there are some beaches that we were even having issues to get their coordinates, to be able to get their address. So that's an issue that we have to work with, and that's something to look into. And then resource constraints. Yeah, so that's a big issue. Only 3 of us or 4 of us. Greg had to come in when there was some setbacks. Greg had to come in, but basically it was just myself, Sai, and Ben that really worked on the data entry and everything, and it was really tasking. It was really tasking. So, that was why we had to limit the number of samples we dealt with to 30, or the data set to 30, so that we could make up, get ahead of something. So, manual data entry and lack of automation in data processing is a big issue. And then, even after the collection, I could remember there was a time I had to tell my team that, this data that I entered, I need someone to give a second look. Because once you put in the wrong data, it's definitely going to affect the whole story. So I was going to bias the whole story, let me put it like that. So yeah, it's going to affect the validity of the whole story. So if that can be made, or it can be automated, and then maybe more resources can be put into that, yeah, I'm already going to the solution. Right, so but these are the challenges. Then the variability in the factors as well. So other environmental influences like pH runoffs were not accounted for in this research, and those are factors very, very, in fact, even more than the factor that we considered that could be responsible for beach contamination that we could look into. Take for example the water temperature. Although the temperature of the environment can be a pointer, right? But the water temperature is a more accurate, would have been a more accurate factor to work with, because that talks about the water itself rather than the temperature of the environment or of the surrounding at that particular time. So the solutions that we generated, that we thought of, which can be further improved, right? First is the collaboration with local departments for complete and accurate reporting. So yeah, so we want them to, sample more, report more, and report in time, right? And then recommendations for weather reporting sites. So IDPH is a government entity, so I believe there should be room for collaboration with most of these websites. For the purpose of research that will further improve get policies, recommendations, and then further improve beach monitoring practices, and even in other programs as well. I'm sure there are other monitoring, some sort of this kind of project that could be further influenced by these. So collaboration, interagency collaboration is what we recommend in terms of these, to make, even if it's not available to the public, or maybe we can have some access to this information, to this data, or further improve the practices. Also improve data analysis. So yeah, automation tools for efficient data entry. That will save us the stress of entering data manually and all of that. Then expand predictive models to include other environmental variables. So like I said, other variables that are not captured in the course of this research can also be looked at. The water temperature and all of that. Then encourage beach sampling reports from the regulatory agencies. So we want them to sample more. Like I mentioned earlier, I want to encourage them to sample more. So basically, I've really talked in length with this, but I will just say a few things. Weather patterns significantly impact coliform levels. Like I mentioned, the temperature and the rainfall, precipitation, they highly influence the coliform levels. And then this is meant to actually give us the proactive nature, like proactive approach to measuring the coliform levels, right? So when we don't need to wait till the next 2 weeks once I sample. Once I notice that, oh, this time there's a rainfall, there's a heavy rainfall, or the temperature is very high, I go ahead and sample that beach immediately. And once it comes out, I do the needful. So I don't need to wait till when it's the time for me to sample per day. And then that time you're able to save people, you're able to prevent people from being exposed to the risk of swimming in that particular beach at that particular time. So yeah, so that is a very important thing to note. So right to the policy recommendations, I talked a lot about this. Integrate weather forecast into sampling protocols. So you usually, once we notice that this is the temperature, the pattern of the weather, we want to sample immediately within 24 to 48 hours. And then based on this, increase the sampling frequency. So the more we are proactive with the approach, the more we get more samples to work with, and then the more we get more data set to work with, and then the more this research can be further improved for better research in the future, all right, and then get more outcomes, all right. So implement dual risk monitoring. So we are not only monitoring the coliform level, we're also monitoring the weather as well. So that's the dual risk monitoring. We are monitoring the weather pattern as well, and as well monitoring the beach, the coliform levels. Yeah, so we want to, that's also something to take note of. And then focus on underreported beaches for compliance and enforcement. So yeah, like I said, this research has really opened our eyes to the fact that apart from the fact that those beaches that are not sampling, we don't even know, maybe they are sampling and the result is bad and they are not sending it to us, or maybe they are really not sampling in the real sense, right? So if they don't sample, that means the public has risk. So apart from that fact, the fact that we don't have enough, when we want to do educational or academic exercise like this, we don't have enough data set to work with to be able to generate, then also promote interagency collaboration for comprehensive data sharing. Like I mentioned, the interagency collaboration between IDPH and weather reporting website and all of that. Then education of beach managers as well. We want to educate beach managers based on this, the benefits of this research that, once you sample, you don't need to wait till 2 weeks. Once you have, there's a change in the weather pattern, you want to go ahead to sample immediately. And then, yeah. So, so to conclude, weather analysis demonstrates the feasibility of optimizing water sampling protocols using weather data, right? So from this analysis, we were able to demonstrate the fact that, we can improve on what we have already, based on this result. And then temperature and precipitation are key predictors of coliform contamination, right? And then implementing strategies can enhance public health protection based on these. Future directions, like my team will say, post-senior era. To expand research, we want to expand research to include additional variables and refine the model, right? So we want to look at other variables that could be responsible for the contamination of these beaches. Then also continue developing innovative tools for real-time monitoring and risk assessment. Yeah, so my acknowledgements, my special gratitude, like I mentioned earlier, goes to Jerry for giving me the opportunity to do this, and then to my supervisor as well, Greg, for putting me through, at each stage of the project, and even right from the start of the program, of my internship program here, and then my beautiful colleagues, appreciation to them. I really appreciate their support. So this is my reference, and then thank you for listening. All right. Yeah. Any question? Yeah.
I have questions, but I don't want them recorded.
Okay. So I got that stopped.